Hi, hello. This is Renu, and I'm going to talk to you about uh, Git workflows and CI/CD workflows. It's going to be a beginner tutorial, so it's going to take something which it's going to think that you have almost no prerequisite knowledge, and you're here to learn about these newly. So there wouldn't be any prerequisites required. What we're going to do today is going to talk about Git workflow, have a Git activity, have a CI/CD workflow, have a CI/CD activity. Let's get into Git first. So, what is Git? As you know earlier, Git is a very popular version control system. Uh, GitHub, Bitbucket, GitLab, all these are cloud-based Git hosting platforms. What Git does is it helps in collaboration. So if you look at this chart, there is a master copy of the code. And now you're starting to work on a feature. So you branch off and you keep working, add commits. And now, at the same time, someone else has started working. They have some features, and at the same time, the main copy has had some changes. Now, how do you combine all this? Don't you think it's too confusing, too crazy, too chaotic? It was chaotic until Git came into the picture. So Git helps you to merge all these changes together, helps you collaborate. So what happens is after this blue, you're trying to merge with the main branch. So the previous commit is what previous few commits is what is relevant to this. So based on this, it merges and a new commit is created. Now, since another person has um, branched out, now how do they merge? They merge after your merge conflict is resolved, and this is the final commit. So it ultimately helps in collaboration, helps you to combine your work with your colleagues' work and maintain a good version history so that you can always go back and see what you've done, what was added, what was removed, who made this commit, why was it made through the Git commit messages. So Git is ultimately a boon for software engineers, or basically anyone who works with software in general. So let's get started with a few Git commands. Uh, the first thing is git clone or git init. What git clone or git init is? I mean, both of them are different. Let's say you want to create a new Git repository. You do git init in your directory, and that directory becomes a Git repository. Let's say you have a GitHub link or repository hosted online. Just type git clone space repository link. It'll download that Git repository on your local, and then you'll be able to uh, uh, use that repository on your local. Now, that's the first step. Second step is staging. So, what is staging? Staging is basically telling that you are ready to commit something. It's basically something that, uh, um, let's say you're making changes in a file. Let's say file name um, uh, sample.txt, and you're added a few changes. You created another file, sample2.txt. You made a few changes, but you only want to commit your first file. You want to discard your second file. You don't want to consider your second file which you changed. This is a real scenario, can definitely happen. So you just type git add space the file name. It'll be added to your staging area, and then you can commit it. What is commit? Commit means So there's a version history. So if you see this Git log chain, each chain is a hash, which tells that there was some change over here, and then there is a message, corresponding message along with it. So um, in Git, so when you do a Git commit, all the items in your staging area gets committed, and when you do a Git push, all the local changes to your push are pushed to the GitHub cloud. Now, a small exercise, you'll have to navigate to this URL, fork this repository, and clone this repository on local. Then create your branch, check it out, add a file called test1.txt, add to Git staging area, then do a Git commit, Git push, then open a pull request from your branch to master and merge it. So that's going to be an activity. It will take a few minutes. I'm going to skip that. Other Git commands. So, so once you get started with Git, you need to have Git. You need to basically give the config, Git config. You can better give global user.name, Git config, global user.email. Then some commands to create a Git repository. Uh, Git status. So Git status is one of the most useful command which is I feel you can see whether it is being uh, staged, whether it is committed, whether what exactly is happening. You can see that Git branch will effectively create a new branch. Git branch space name of the branch. Git checkout will create a new branch. I mean, it will basically move to switch to that branch. Staging area, unstaging area. I've told you about this. Um, Commit, told you. Git push to remote branch, told you. Git pull. So what if your friend has pushed some changes, and then you want to pull the recent changes? Git pull origin develop or master. So then Git stash. Stashing is like you can call it as a temporary storage. So you don't want to commit certain things. You want to switch to another branch while you want to retain your changes and then come back for it. Use Git stash. Mm, Now let's quickly go to a pop quiz. Developer needs to securely integrate OpenAI API keys into their project while collaborating via Git. Which approach follows security best practices for CI/CD pipelines? Okay, there's some API keys to be added to the project. What is the best uh, best way? Hardcode the key directly into main.py and commit it. Store the key in config JSON but exclude it in git ignore. Mm, Use environment variables with a .env file listed in .git ignore. Encrypt the key using git crypt and commit the encrypted file. Okay, the answer is C. Use environment variable, which is the most safest, and then list it in .git ignore. Um, So um, the reason is pretty clear. You don't push any of the keys in your GitHub because it's all publicly available. Even if your repository is private, your keys will be publicly available. And there was one instance where one of my keys went into Git by mistake. I mean, one of my developers had pushed it and deleted it, um, and then made a commit and pushed it, but it was in the commit history. Still, it got recognized and it cancelled. Okay. Continuous integration. What is CI? CI is basically a method where, um, how do I explain? Let's take an example. Um, there's going to be a dustbin. There's going to be balls. You're going to throw a certain a few balls in the dustbin and uh, consider the ball as a code change, consider the dustbin as a central repository or a code piece. And now, when you throw the ball to the dustbin, um, unit test runs automatically or build runs automatically. So, see, this kind of automation. So, every time you make a change and push it, there is going to be uh, an action where it automatically runs the unit tests, runs the linting, runs the build, all those things to test whether your change is correct or not. Because we don't want any random push to break our production. So certain things which run automatically, um, it gets triggered automatically as when you push or make a pull request. That is CI. So CI automates the process of integrating code changes regularly from multiple contributors to a shared repository. Imagine developer commits code, code is pushed to version control, automated build process starts, unit tests and other automated tests run, feedback is given to the developer immediately. CT automates delivering applications to production after successful integration with IO manual automatic deployment. Let's say you just push a change, you want it to be uh, deployed. You want it to be deployed ASAP, automatically without much effort. So that is CD. Post CI artifacts are generated. So see if you're running a Java or something like that, certain executables will be generated. Um, then deployment to staging for testing. So, so let's say, for example, if you use Docker, you Dockerize the application and keep it ready for deployment. That happens in CD, and then it triggers the deployment to either staging, production, etc., and then it monitors for feedback. So this is continuous delivery. Here, code, created code, make a commit, build triggers, integration tests, all these linting CI pipeline triggers, and then CD pipeline starts after CI, where it's all deployed automatically. This is a small activity. Use it semaphore CI, create an account, create a new project, choose the same repository which you forked, give access, proceed with the creation, run the workflow. You will make changes, go to the repository, your branch, make file changes, open pull request to master, see the build status there. This is how the CI/CD pipeline looks on Semaphore tool. There are different versions. You can implement it however you want. I'll leave it up to you. Semaphore is one easy way to get started because this is an introduction level course. I don't want, I haven't talked much about Dockerizing, containerization, uh, haven't given much, haven't gone into depth on CD, but you go step by step. We start with CI, try to understand how it's working, and then have simple basic deployments. Uh, and then you can think about serverless deployment, containerization, all those things. So one such example is I used Google Cloud for CD specifically because um, I was able to Dockerize my application and then automatically have it uh, deployed on Cloud Run. Um, More specifically, it's called Cloud Build. So whenever the CI pipeline is complete and it triggers, uh, this Cloud Build starts, it pushes the image into the container registry, and then Cloud Run pulls it and deploys it. So, Quest, the developer creates a feature branch, adds new API endpoint, opens a pull request, CI/CD pipeline runs these things, PR password checks, but it can't be merged due to merge conflict. What should the developer do to resolve this? Read on CI/CD, git fetch origin, and get rebase main, delete the feature branch and start over, force push to main branch. It's git fetch origin main and get replace. This fetches the main branches and replace the feature branch comments on top of them, resolving the conflict locally before pushing the updated history. Then CI/CD pipeline will automatically run. It's all. So closing thoughts, the biggest risk is not taking any risk. In a world that's changing really quickly, the only strategy that is guaranteed to fail is not taking the risk. So, and this is by Mark Zuckerberg. One more quote: if you don't innovate fast, disrupt your industry, disrupt yourself, you'll be left behind. So, thank you.